Digitalization is changing everything.
Hello, my name's Alastair.
I am Magnus Edholm. So over the last few years, we have seen a change in the way we are ordering our products, how we find them, how we configure the products to fit into our lifestyle. And this has, of course, had a profound effect on the manufacturing industries. They're facing new challenges. Pretty much anyone involved in the manufacturing industry has felt this.
Why don't we already give the audience a tangible example? So Magnus, you have a cell phone in your pocket, take it out.
I'll put it behind the scene, actually.
I have a cell phone, I have a cell phone.
Yeah.
So over the last 5 years, this cell phone has changed dramatically. You all know this, the screen's got larger, it's much thinner than before. But the material it's made out of has also changed. 5 years ago it was plastic, now it's made of metal.
Is that cheaper, or what was the deal?
No. Actually, the molding process used to make those plastic parts was incredibly cost-effective and fast.
So cost-effective and fast, and still you want to change this concept.
Magnus, the problem came when you wanted to change from one generation of the product to the next one. You wanted to change the design. You see, it took months and months to redesign, manufacture, test, ship and refit those machines with new molds.
Okay, so the problem is such. The very minute you get your new smartphone, you're very happy with it and proud. It's more or less yesterday's news, and the hype is all about the next generation product, right? So if we take a look at that particular industry, we see that the innovation cycles are getting shorter, it's more intense, and to narrow it down, it's basically just about speed, Alastair, right?
Exactly, and manufacturers were finding themselves in a situation where their product was obsolete, but they weren't yet ready to manufacture the next version.
Right. So the market has basically moved from using NC machines to manufacture those cases. And this is due to the tight link you have between the CAD, CAM, and the NC machines. Basically, you can introduce a design change by the click of one button. So you have an instantaneous update of the design.
Yeah, this was a huge step forward, going from waiting for months to instantaneous. Manufacturers took thousands or tens of thousands of these machines, installed them in their factories so they could ramp up production. And who would have thought 5 years ago that this was a valid business model, but now it's the norm. It's a great example of digitalization disrupting the industry.
Okay, so we have it. CAD CAM, and you're good to go to the digital world.
No, hold your horses, Magnus. That may be true for cell phone cases, but innovation's driving down the cycle times and the lot sizes of every industry.
Right. So cell phone manufacturers has taken a huge leap in regards to speed, flexibility, quality, and efficiency. And this is something all industries should start be doing. I mean, you'd be doing trains or aeroplanes or high-tech electronic equipment or have you. It applies to all industries.
Even personalized medicines. And these are all very complex products you're talking about. So there is no ultra-simple solution. You can't automate your way out of these challenges. And if you focus only on the automation aspect of manufacturing, then that's just not enough anymore.
That's correct. So what needs to be done then? Well, you need to weave a digital thread throughout the entire value creation chain, starting from design, manufacturing planning, the engineering phase, the production, and also, of course, services. Kind of a carpet of information throughout the entire value creation chain. And once you have your complete value chain digitalized, you got your supply chain included, that's the very moment when the magic is happening.
Yeah, and that's really not a joke. For those of you who have not seen this, it wasn't even a very good joke, but this is really an amazing point. It's one of the key messages in our story. We are able to take the digitalized and integrated value chain, and we are able to make a copy of it, a digital twin, a virtual world that runs in parallel to the real world, a world with products, even those complex ones, the equipment, the processes, and we can use simulation to determine how these interact, to understand if there'll be blockages, if there will be problems in the future, and we can resolve those in the virtual world before our customer ever has to commit resources in the real world.
So when I listen to you describing this, Alastair, to me it sounds like, I'm not a gambler, but I could tell which horse would win the race before the race even started.
Exactly. It's kind of cheating. I like to use another analogy. It's like you can throw yourself out of an aeroplane knowing for certain that your parachute will open because you've already seen it in the virtual world.
Extremely important information if you're stuck in that situation. So now we've been talking about this value chain for a while, and I will actually take you through a few of them steps, and we're going to use one of our own Siemens product, the IPC NanoBox, an industrial PC, about 1 liter of size, very compact, very sturdy. It is put to work in a very aggressive and, I would say, violent environment. We're talking about vibrations, we're talking about hot, warm temperatures, cold, electromagnetic fields, etc. Basically, those are the requirements that this little IPC is facing. So when you start to design, you collect the requirements. You kind of see what are customers expecting of this product. So once you start to design, the design engineer knows exactly how he needs to do the design of the IPC NanoBox. In this case, we also try to reuse as many components as possible to, of course, also in that area speed up the design process.
This is really cool, Magnus. It's very, very lifelike, but it's still inside a computer. So I imagine that the next step of our process is to build a physical prototype and test it to see if it works, right?
No. We're talking digitalization, Alastair. It's a difficult word for me to pronounce, but it's fairly easy to understand. So we have the NX CAD, CAE, and CAM solution. It's in the integrated software. So the design engineer is modeling the NanoBox, and then the simulation engineer takes this information, he knows the requirement, and he builds a simulation to test those things, the vibrations, the heat development, etc. And would he discover a problem at this phase, he can easily communicate that information back to the stakeholder or the owner of the design, all in a virtual environment. That's the digitalization for you.
Yeah, we build the intelligence directly into the model itself. So all of the engineering colleagues can collaborate around this model. They can simultaneously engineer the product and its performance without having to rely on a kind of final step of system engineering, which slows everything down. And we do all of this in the virtual world without building a physical prototype.
Alastair, I'm proud of you. You just explained systems-driven product development. Amazing. Basically, as you said, you take the requirements, you do the design, and you build a digital twin of your product that you, of course, can use in the next step, the production planning. You want to make sure you can build this NanoBox. In this movie, we're using Jill, a digital mannequin. You can use her arms to see what she can reach, use her eyes to see what she can see. I can even check what forces and torques are affecting her spine, especially in the fourth and the fifth vertebra, where most work-related injuries actually occur.
That's awesome. I love the idea of digital people in our virtual world. But our customers are also asking us a lot about robotics. And I don't mean, those big robots in cages. They want things that sit on the shop floor with a couple of arms and can help the people in the assembly process. Can we deal with those?
We can. So basically take Jill out of the picture and I put in a robot there instead. So we got here is a dual-arm robot. We program it in our virtual world, making sure we don't have any collisions, which may occur if you're in kind of a narrow environment. Bang. You want to discover that type of collision in the digital world because it doesn't hurt anyone, you don't break any resources. Those are the benefits of working in this environment. Let me take you to one more step along the production line. We have requirements regarding the product, but we also have requirements regarding the output, the volume. How many do we need to produce of the IPC NanoBox? That we can check with plant simulation, basically discrete event simulation. How many components are floating through the factory? Do we have bottlenecks? We can even check the energy consumption of this facility digitally.
It's amazing. This is really where it all comes together. I've got everything there. I've got the people, I've got the robots, I've got the logistics. It's awesome, but it seems to be kind of running at real-time speed. What's the point of that?
Well, the point is, dear Alastair, that I can tweak this baby so it runs with like 1,000 times of real time. which means that I, within minutes, can simulate like a month worth of work, or perhaps even a year.
You can look into the future a year.
I can look into the future. That's your crystal ball right there. So, now we've been through step number 1, the design phase. We've taken the digital twin and used it also in the production planning. And in this way, we have checked every aspect of the production process.
Okay, so I was right. This virtual world is awesome. The question is, can it really work in the real world? And the answer is not until my automation code is written. It's normally at this point when our customers send an army of engineers out onto the shop floor and they start coding the PLCs. Essentially, the digital thread is broken. Well, we want to create an end-to-end digital enterprise. And so we're extremely proud that this year, just behind you in the booth, we can show you the first truly integrated mechatronic engineering suite. We're taking the mechanical aspect of your robots and your equipment, and for the first time we're extending it to cover also the entire electrical and automation aspects of the machines. Check this out, Magnus. We're actually taking all those movements and we're using it to derive all of the automation code. No more writing automation code. We're automating the engineering and we're downloading it into the tier portal so it's ready for production.
Amazing. So instead of asking our customers to take their PLC code down to the shop floor and test it on a real system, we actually take the controllers and hook that up to our digital twin, a virtual world, making sure that the program is bug-free and everything. And that's, we call it virtual commissioning.
That's another thing you can see behind you in the booth. We have a real robot, we have a virtual robot, and we can switch our automation to control the real one or the virtual one. It's very compelling. Now, we've completed our digital twin. We've designed and defined the product, the process, and now every aspect of the equipment. And I really talk about these in separate parts of a digital twin, but they're fundamentally integrated. And it's this integration which allows our virtual world to act and react as though it's real. That's where the real value comes from.
Right. So now we take this optimized digital twin. We, of course, communicate this to all the stakeholders involved in this process using our amazing collaboration platform, Team Center. So without delay, without uncertainty, this very moment is where the rubber hits the road.
The rubber does hit the road. And this is another point in a traditional company where the digital thread can break. Engineering and operations are usually disconnected, but not in a digital enterprise. So the trigger for us to start production is usually an order coming from the ERP. But because the ERP doesn't have access to our integrated technical data model, our digital twin, well, the order schedule it sends down is not very optimized. All these black bars here, they're changeovers, they're waiting times, they're lost opportunity. And we're going to take that, we're going to reschedule it using the detailed information in our digital twin. It's now fully optimized, all our resources are allocated correctly. And we're going to take every one of those orders, and an order now can be a lot size 1, and we're going to associate it with our digital twin, with our bill of process. That's the kind of manufacturing blueprint you can see up there, sitting at the enterprise level. And we can push that into our plant in Mexico, in China, in the US. There it is on the shop floor now, ready to execute. That execution is done by the MES system, the manufacturing execution system. It'll use the bill of process to coordinate and synchronize all the resources, the people, the machines, the logistics, and it'll make this product right first time. And it has to, because if we only have lot size 1, if it's an individualized product, if we don't get it right first time, we go out of business.
Right. But we also need to keep in mind that many of our assembly operations are still manual. And throughout the journey from design through manufacturing, planning, and so on, we have generated a lot of information. And we can use it as electronic work instructions. So this information is now sent down to the shop floor, to the assembly line, to the correct and the right operator at the very right moment in time so that she or he can actually assemble our product in a best manner possible. We can use it on a normal monitor, or as you can see here, a tablet PC with augmented reality. Really, really cool stuff.
We want our plant and the people, the real one, to behave like the simulation. So we blend the real and the virtual world. And again, this is another compelling demonstration that you can see in our booth afterwards. So, as the production continues, the MES is creating an as-built document, which we can continuously compare to the as-engineered and as-planned definition. And we can find any deviations. Those deviations can be used to keep production on track. Any defects we find normally would stop production, because the poor operations guys, they don't know how to deal with them. But in a digital enterprise, engineering and operations can work together. The operations can reach into the digital twin, redline that digital twin, that model with the problem, and hand it back over to engineering, and they can collaborate in order to find an effective and fast solution.
Right. So at this moment in time, our product is produced, it's made on time, on spec, and of course also on price. So you would think now, okay, that's when the life cycle stops. No, it does not. So if we take a scenario as such, let's say you're a machine builder, then it's very likely that your machine is actually put to work at your customer's side, producing products, but also generating a lot of important data that we can analyze and use to actually optimize the entire process and the entire machine and schedule maintenance work, etc. So you have a very nice ownership experience, to be honest.
Precisely, and if I am that manufacturer, I'm using the machine, I'm going to be producing products. Tens of thousands, hundreds of thousands of products, and selling them into the market, hopefully. But they're smart products, they're generating data too. And just like we did for the machine, we can capture all of that data, aggregate it in our cloud, derive insights about real-world performance of that product, define firmware updates and push them into the running products in our customers' homes and factories. And we can take all of that learning and we can build it back into the next generation of the product seamlessly and easily.
Right. Speed, flexibility, quality, and efficiency. Alastair, seriously, what else do you need?
Well, nothing really. We've taken our value chain and we've made it agile. Now our company can navigate in the market, navigate towards opportunity, away from peril. And we can take the classic PLM, MES, and automation domains, and we can weave them together into a digital enterprise, one that is capable of delivering true closed-loop manufacturing.
Right, so basically take advantage of the virtual world to deliver answers to requests from your customers with just ridiculous speed, correct?
And when the customer says yes to this individualized design, we can press another button and use the digital thread to produce it in the right factory. And it will be right first time, because we already tried it 10,000 times in the virtual world. And all the data it produces, we're going to build back into the virtual world so that our company is growing and improving every time. Now, a year ago, Magnus, we stood on this stage and we described how we had built 15 years of digitalization experience into, not us, Siemens, not only us. 15 years of digitalization experience into a unique product portfolio called the Digital Enterprise Software Suite. Well, we're very happy after 1 year to tell you it's still completely unique. There's still no other company out there creating an holistic solution for digitalization. But during the last year, we've taken another step forward away from our competitors, because we built into our suite full data and lifecycle analytical capabilities. And it doesn't stop there, because every year when you come back, you'll see more amazing things that we have invented, developed, and built into that product. So if you buy into our Digital Enterprise Software Suite, you're going to be able to take advantage of this year after year. With Siemens, digitalization doesn't have to be a dream. It's reality now, and we invite you to take that opportunity and start building your own digital enterprise.
Excellent. So we've come to the end of our little presentation, and now Alastair and I kindly invite you to meet our colleagues in the Digital Enterprise Courtyard, basically on, well, just behind you, to be honest. and you can follow the development of the IPC Nanobox. So everything we showed on screen, you can actually see there and take a closer look at the digital twin and how our digital enterprise software suite can actually help you in your work. Thank you very much for the attention.